Welcome to part 2 of our introduction. We want to recall a couple of definitions regarding cyclic groups, of course, and then give one brief detail that may be new. All right. So we want to recall definitions for cyclic groups and cyclic subgroups. So let G be a group and let A be an element of that group. Then the subgroup that is generated by that element, right? So that's what this is referring to. We take the element A, raise it to a power, and we can raise it to any power, right? It's not just what can I get by A times A and then multiply it by A again. No, we're using exponentiation. So like we get to the negative first, so we get the inverse of A. We get A to the 0, so we get the identity element E, these sorts of things, right? So we want to remember that about our cyclic groups, and that's definitely important. As we generate these cyclic subgroups or these cyclic groups, then we are raising it not only, or not, I guess not just multiplying the element A by itself, but raising it to any integer power. All right, so the subgroup generated by this element is exponentiation by any integer, right? It's called the cyclic group of G generated by A. Actually, you know what? I missed a word there. It's a cyclic subgroup, or sorry, I missed part of the word. Cyclic subgroup of G generated by A. Excellent. So we can take that a little bit further and just say, well, what if we're just generating the whole group itself? Well, then it's just, we say that G is cyclic and that the element A in G generates G. So that's fine. So this is the notation for the group that is generated by A or the subgroup, depending on the scenario you're looking at. So we have A generates a group. If it generates a subgroup, awesome. If it generates the whole group, cool. We call the whole group cyclic in that case. All right, so finally, just the order regarding the order of the groups here. If the cyclic group A generated by A of G is finite, so if the cyclic subgroup, I don't know why I kept missing the word sub here. I'm not sure what's going on. All right, so if the cyclic subgroup generated by A of G is finite, then the order of A is the order of this. So we're defining here the order of A. We've already talked about the order of a group, so this notation is not necessarily new, other than generation here, right? Generating the subgroup. But if the cyclic subgroup or the cyclic group is finite, then we say that its order is this. If it's not finite, then we would say that it's of infinite order. So again, referring to the element itself there. What is the size of the group that is generated by the element A? That is the order of the element itself. All right, so that's all that I wanted to share for now. Joining back in the office for a little bit more. Again, we'll talk about some theorems, maybe some things that are new. I'll oftentimes give proofs. If you don't want to watch the proofs, I'm not going to be upset about that, but they're there primarily so that way you can get exposure to proofs and maybe become a better proof writer yourself by watching those. So I'll see you guys back here in the office in just a little bit.